Okay, greetings. Welcome. I probably went way over. I mean, this assignment is killer. All right. I mean, it's kind of tough, and I'm going to give you some extra time to do it, and at least until next Thursday to get her done, I guess. But I really like air pressure in that we have because we disregard it so much in Physics 210, and I'm forcing you to do some pretty advanced calculations here. I mean, they're straightforward, but so that you can get a sense of what science is like and what physics is actually like, and that you're quite capable of doing it too. For some of you because I read all the essays that were done on time so far, and on the math phobia, and as I thought, 2/3 of you um, had horrible experiences in math class, and a third of you thought math was easy peasy, like I did for the most part. Until I took Calc 1 when I was majoring in fraternity as a freshman. And I had this Calc 1 class at 7:30 in the morning there at Mizzou, Monday through Friday. 7:30 in the morning, Monday through Friday. Are you kidding me? You expect an 18-year-old to go to that? Anyway, um, so that's so that's why we're doing it this way. And I love fluids, and I like the way it makes, because we do a lot of cool things with them. And then our exam will actually be a project. Exam 2, I'm going to call it Project 2. And basically what we're going to do is we're going to do a Salvador Perez home run, and just kind of go in depth with what that looks like in some of the baseball things. Rose blew one last night. They've got it. I mean, Mendesi, his worth is off the charts as far as the raw talent that's there. The guy just can't hit. I mean, he he, he couldn't hit water if he fell out of a boat. But anyway, because we had it, runners on first and second. They're in the bottom of the 10th, ninth or 10th. I think it was bottom of the ninth. First and second, Mendesi's up, 3 pitches. I mean, the relievers, the pitcher is just like, oh, cool, he's up. Foom, 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 foom. Bye, Felicia. So anyway, he was done. Well, let's go ahead and get started as we talk about fluid. Now, this is a little bit of a repeat of your last lesson, the one I phoned in on y'all. When I just kind of phoned it in. I just repeated last semester's, which I might have even repeated last year's, which is Bootsy. So I won't do that I try and keep that to a minimum. And the next one's really cool. Next assignment's really cool. What the hell is that? We don't care. All right. So here we go. All right. We're going to talk about fluids. Okay. And I wish we're really going to be talking about air pressure. Okay. Really talking about air pressure. I mean, we could spend forever talking about, and the equations on this stuff. We get into Stokes theorems and stuff with fluid dynamics. It's amazing things, but it's really kind of hard. All right, so tennis balls get their bounciness because they are under pressure, about 2 atmospheres. All right, right now you've got 1 atmosphere pushing on you. And pressure on Earth, what are we talking? We talk about pressure, but what is it due to? What is the pressure on Earth? All right. What are you talking about, Woo? If we can quote Al Swearingen from Deadwood. But anyway, so here's the pressure. If an object is in a fluid, the fluid above will exert a weight on the object. So you get this thing. You go, da, 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 da. There's the air pressure pushing down on us. And it is equal to, the pressure is equal to the density of the air or the fluid times gravity times the height. That's the pressure. Okay, and so if the atmosphere is 10 kilometers and the density of the air is 1.2 kilograms per meters cubed, then you get 117 pascals, which is about 117,000 pascals, which is we use. It's about 14.7 pounds per inch, or 15 pounds per square inch is the amount of pressure. So that's like a big ass bowling ball on every square inch of your body, smashing on you right now. That's a heck of a lot of pressure. And it changes, it fluctuates, and it doesn't take much of a fluctuation. Low pressure brings in wind. I mean, there's just all kinds of cool things with 1 atmosphere. It's also called 1 atmosphere. Okay, and we've got the pressure vacuum cannon. This is ours in our physics department. We made one. We blasted through. Now I've got what I want you to do is I want you to watch right now that little Cub Scout video on the air cannon. Okay, and then we'll go to your homework and we will look at the problem that I have associated with that. So take a few minutes, watch the Cub Scouts blasting with the air cannon. It's a lot of fun, and we'll talk later.